All right, let's talk about Chapter 5, thermochemistry. We're looking at energy involved in chemistry. So we're going to talk about basics of energy, what we mean by energy, what are the units involved. We're going to talk about calorimetry, which is where we go to the lab and we actually measure heat lost and heat gained. And then we're going to look at enthalpy. And enthalpy allows us to get out of the lab, look at values that are tabulated, and calculate energy with these tabulated values. So, three topics: energy basics, calorimetry, and enthalpy. So, let's start out with basics. Thermochemistry is the study of heat absorbed or released during chemical, we could also do physical, we tend to do chemical, but changes involved in chemistry. We care about this a great deal because it's part of our everyday world. We care about the burning of gasoline because we know that produces energy. If we're going to make something from raw materials, we need to know if energy is going to go in or energy is going to go out. We know that when we metabolize food, our body uses the energy that is produced as the bonds in this food are breaking, and we use that to get energy to exist. Energy. Energy is the capacity to supply heat or to do work. We have two types of energy. We have potential, which is stored. It can be of composition, and that, for example, is in chemical bonds, which is probably the kind that we most care about. We could also do relative position, something above something else would have a higher energy. We also have kinetic energy. That's an energy that something has because of its motion. And this frequently is involved with temperature. As the temperature goes up, kinetic energy of something is going to go up. And we see that as well in chemistry, and we saw that in gas laws. The energy of the water here going over the waterfall is kinetic. The energy stored here behind the dam would be potential energy. The first law of thermodynamics. We're discovering Chem 112, we've got a couple more, but the first law of thermodynamics says that energy can be neither created nor destroyed, but it can change form. So it's going to be converted from one form to another. And this is the law of energy conservation, or the first law of thermodynamics. So we know that here energy is conserved, which means it cannot be gained or lost. It's going to be just transferred. So let's consider thermal energy, because in general, we really do not like doing work in chemistry. With a quick note on chemistry and work, work is force times distance. Force times distance is straightforward if you've got like a rock rolling down a piece of road. But here in chemistry, work and force times distance works out to be pressure times the change in volume. If we have pressure times the change in volume, believe it or not, we get units of force times distance. The problem with something changing in volume is it means the volume of something has to, for example, expand. Well, the volume of something expanding is an issue if you have containers like a nice Erlenmeyer flask in your lab that's made up of glass. We do not want the volumes changing. So in general, in chemistry, we do not do work. We try to do entirely heat. Heat is our thermal energy, and we do that by leaving the lids off. If we don't seal this, sealed, it can change volume. Unsealed and open, the volume is going to be constant, and we will not have any work. So heat, or thermal energy, is a type of kinetic energy associated with random motions of atoms and molecules. Temperature is how we describe, and it's quantitative, of hot and cold. So if we say that we've got fast moving molecules, they've got lots of thermal energy, and they're hot. If they're moving slowly, we say that they are cold. And with this, we can measure heat flow. Heat is the transfer of thermal energy between two bodies of different temperatures. Heat flow, heat, by the way, is heat flow inherently. It's going to increase the thermal energy of one and decrease the other. Heat is always going to flow from something that is hotter to something that is colder. And heat flow will continue until they are both at the same temperature. So heat is a transfer of thermal energy. When we have chemical reactions, we have reactions such that they can release or absorb heat. when something releases heat. And when we look at these, we're always going to look at the actual reaction. Now, this can be tough because we rarely ever experience a reaction. What we experience is the surroundings around the reaction. What do we mean by that? Well, if a reaction loses heat, so we've got a reaction and we have reaction going into products and heat comes out. Well, if heat comes out, then when we take and we feel this reaction, it's going to feel hot. Now, it feels hot to us. Now, what happens though with the reaction is that the reaction itself is going to lose energy. So when a reaction loses energy, we around it gain energy and it's going to feel hot to the touch. A reaction that absorbs energy, so we have some reaction gaining heat going into products. In order for a reaction to gain heat, it has to pull heat away from its surroundings, and that, for example, is a cold pack. A cold pack absorbs heat from its surroundings, so it feels cold. It feels cold by taking the heat from the surroundings and putting it to the reaction. So we have two types. We have an exothermic, exo meaning out, and heat coming out, and we have an endothermic, endo meaning in, where heat is going in. We see this in an acetylene torch, which is going to feel hot, and a cold pack, which is going to feel cold. The sensation of cold is the sensation of heat leaving the surroundings, going into the actual reaction. You can buy hand warmers, chemical ones that are reusable. These hand warmers, when you take and you press this little disc in here, it causes a compound in it to crystallize. And when it does that, you get heat out. So because heat is leaving the reaction, so the reactants are going into products. And as this precipitation occurs, heat is coming out. The heat flows to the surroundings. This is an exothermic reaction because heat is coming out, and this is going to feel warm as we touch this hand warmer, we are going to gain the heat that is released by the reaction. Some traditional units of heat or energy. Traditional unit for heat was a calorie. A calorie, by definition, is the energy or heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So we say a calorie is going to take and increase the temperature, so raise temperature of 1 gram of water 1 degree Celsius. Now remember here that the temperature size of a degree Celsius is exactly the same as the temperature size of a Kelvin, so you could have either 1 degree Celsius or 1 Kelvin. Our food is not a normal calorie, it is a capital C calorie, which is also a kilocalorie. So if you have an apple that contains 70 calories, being capital C, that is 70,000 lowercase c calories, and it says you could raise the temperature of 70,000 grams of water 1 degree Celsius with the heat that is stored in the bonds of the apple. The SI unit of heat is a joule. And a joule here is the amount of energy used when a force of 1 Newton moves an object 1 meter, so it's a Newton meter. But the reality is, what do we care about? What we care about is there are 4.184 joules in 1 lowercase c calorie.